In this class, we are going to discussing about how to draw the shear force and bending moment diagram of a various types of beams. In this case, I am consider simply supported beam with a point load. For this case, how to draw the shear force diagram and bending moment diagram. Now let us consider one example of a simply supported beam having a point load. Now the point load is need not to be exactly at the center. In this case, I am consider exactly at the center. But if you understand this concept, you can solve many number of problems by taking the consideration of various number of point loading condition on this particular beam. Now you try to understand how to solve this kind of problem whenever you are having a point load in a simply supported beam. Right. The first and foremost step of a shear force diagram or bending moment diagram. Right. Now to solve the shear force diagram and bending moment diagram for any kind of beam, you have to follow this procedure. What is the procedure? The procedure is very simple. There are various number of steps we have to go through one by one. What are those steps means? The first and foremost step is step 1 here. The first and foremost step is first we have to draw the what we call free body diagram of that particular beam. What is the free body diagram? Now let us consider the simply supported beam. Now simply supported beam means we are having at the end of the beam we are having two supports, then only we can call it as a simply supported beam. Right? So for a simply supported beam, right, we are having two reactions on the either side, either end of the side, and we are having a loading condition. In a free body diagram, we have to represent what are the types of forces or how many number of forces that are going to be acted or that are acting on this particular beam is going to be represented in this case of a beam, or in this case of a what we call as a free body diagram. That is what we call as a free body diagram. That means in a first step, first draw the free body diagram of your given beam. So in this case it is a simply supported beam, right? If you observe a simply supported beam, here at point A and at point C we are having two supports, so that we are having two reactions. Let us say the naming as RA and RC, and those reactions are we have in a free body diagram. So we have to represent first one is reaction force. Reaction forces are always acting on the upward direction, and you can represent what are the forces we are acting on a beam that is to be represented. Right, so that is what we call as a free body diagram. So in this way we have represented free body diagram. You please observe. So whenever you are having reactions at A and C, you are having reaction force RA and RC, and you are having only one point load, that is 100 kilonewtons, that is acting on the downward direction, and there is no other forces that are acting on this beam. So that is the free body diagram of your simply supported beam. So that is the first step. So for any kind of problem, the simply supported beam, cantilever beam, or overhanging beam, or continuous beam, whatever it is, the first step is we have to draw the free body diagram of your beam. The first and foremost step. It is very important. Next, in the step 2, in the second step, we are supposed to calculate the reaction forces, the quantify value of reaction forces. Right? That means what is the RA value and what is the RC value. How do you know the RA value and RC value? Suppose if you consider this kind of a simply supported beam, it is exactly at the center. That means total distance is 4 meter, and exactly at the center, that is exactly at the 2 meter of distance at point B, we are having 100 kilonewtons. That means automatically you will get the value of 50 and 50. That means these reaction forces will resist. That means these reaction forces will resist this 100 kilonewtons of forces that are acting on the downward direction. So in order to calculate for any kind of beam, in order to calculate the reaction forces, whatever the reaction forces you are having, it may be simply supported, cantilever, overhanging, whatever the type of beam, first you have to calculate the reaction forces. So how do you calculate the reaction forces? Reaction forces can be calculated upward force equal to downward forces, and second one is clockwise moment equal to anti-clockwise. By considering of these two steps, you can calculate the reaction force value RA and RC. What is the upward force and what is the downward force? Simple thing. What is the upward force means? The force that are acting on the upward direction. Here RA value and RC value are the upward forces. And what are the downward forces? Only 100 kilonewtons is the downward forces. So that we are having RA plus RC is equal to 100 kilonewtons. Okay, so upward force equal to downward forces. Next, In the second case, clockwise moment equal to anti-clockwise moment. So in this case again, clockwise moment and anti-clockwise moment. Clockwise moment equal to here in this case we are having two ends at point A and point C. We are having two ends. Which end you have to consider? It depends upon the what we call the depending upon the problem solving technique we have to consider. Either you have to consider at point A or you have to consider at point C. Whatever it may be, you have to consider on either side, no problem. Here I am considering with reference to point C, right? So with reference to point C, you have to consider what are the forces that are acting on clockwise direction and what are the forces that are acting on anti-clockwise direction. Simple. So clockwise moment means that is acting on clockwise direction. That means in this we are having clockwise moment means in this direction and anti-clockwise moment means in this direction, right? So clockwise moment and anti-clockwise moment with respect to point C. So RA value into with respect to point C, RA into point C. That means RA into total distance is 4 meters. So RA into 4. That is clockwise. So clockwise means you have to consider positive. Anti-clockwise means negative. Here I am considering clockwise is positive and anti-clockwise is negative. So that clockwise moment and anti-clockwise moment. Clockwise RA into total distance is 4. Force into perpendicular distance, that is moment. Next, at point B we are having 100 kilonewtons that is acting in downward direction. With respect to point C, this moment is in anti-clockwise direction. So that we are having an anti-clockwise moment, that is minus 100 into 2. I have told you that clockwise moment is positive direction and anti-clockwise moment negative direction. So by considering of these two equations, RA plus R is equal to 100 kilonewtons, and by considering this moment clockwise moment equal to anti-clockwise moment, so RA equal 50 kilonewtons and RC equal 50 kilonewtons. How do you get this values means? By solving of this equation and by solving of this equation. You will get the value of RA equal 50 and RC equal to 50. Right? This is the step 2 of how to draw your shear force diagram, volume diagram of any kind of beam. Here we are considering only simply supported. This principle is applied to any kind of beam. Right? Right. Now we have to draw the very important step is how to draw, drawing of your shear force and bending moment diagram. In drawing a shear force diagram and bending moment diagram, right, again we have to consider a free body diagram. Right, there is a free body diagram. RA equal 50 kilonewtons and RC equal 50 kilonewtons, and we are having 100 kilonewtons. Right. First of all, we have to draw the shear force diagram. What is the shear force means? It is nothing but the forces, the algebraic sum of the forces that are acting on your beam. It may be either left side or right hand side, whatever it may be. Completely algebraic sum of all the forces that are acting on your beam. That is what we call as the shear force. You have to represent in this manner. That means here this line represents reference axis. This line represents the reference axis. This line represents a reference axis. Right? Reference axis. So reference axis, above value is positive value, below values you can consider negative value for a shear force diagram. Right? For reference value, above value is positive and below value is negative for a shear force diagram. I am considering like that only. And my consideration is upward force is positive and downward force is negative. I already told you that by consideration for upward force is positive and downward force is negative. Right. Now take the value of step by step on each and every location. Now consider at point A. At point A, whatever, so here it is at point A, like you observe in this location at point A. So at point A, what is the value? RA value is 50 kilonewtons. RA value is 50 kilonewtons. And this direction is upward direction, so that positive value. So draw a line of 50 above the reference line, because above the reference line we are taking positive value. So RA equal to 50. So A value is 50, that is 50 value. Right. Next, from point A to point B, in a beam, from point A to point B we are having no loading condition. That means we are having only constant loading from point A to point B. So that whenever you are having a constant loading condition, simply you have to draw a straight line. Whenever you are having constant loading, simply you have to draw a straight line. Right? That is the point. Next, at point B, so that I already represented here, A to B you are having no loading condition. That means no loading condition means constant load. Next, at point B we are having 100 kilonewtons. So 100 kilonewtons will be acting on downward direction. Downward direction means you have to consider negative value. Already at point you are having 50 kilonewtons. From A to B also we are having same constant loading 50, and here you are having B value is 100 kilonewtons. So 100 kilonewtons means, so 50 minus 100, so that minus 50 value. Already told you that whenever you are having a minus 50 means you can represent the value below the reference line. So this is the below the reference line, negative value below the reference line. So already draw the value of below the reference line, that is minus 50 kilonewtons. Right. Next, from point B to point C, again same condition. From point B to point C, we are having no loading condition. Whenever we are having no loading condition means simply draw a straight line. From B to C, only straight line. Right. Again at point C. So we are having minus 50. So same constant load will be applied here. From B to C, we are having minus 50. Right. Again at point C, what happens? We are point C, we are having 50 kilometers. 50 kilometers will be acting on the upward direction. So that C equal to minus 50 plus 50. So total equal to 0. 0 means simply you can touch up to this reference line. So you can call that this is the reference line, or you can call this is the reference line. So you have to touch up to this reference point whenever you are having a 0 value. So this is how to draw your shear force diagram. You please remember that above the reference line it is a plus value and below the reference line you are having a minus value. That is the first point. In the second point, whenever you are having a constant load, that means whenever you are having a no loading condition at any given point, simply you have to draw a straight line. That means you are having a constant load. Here in this case, from point A to point B, straight line. Point B to point C, straight line. You please observe this point. This is very important point. So this is how you supposed to draw the shear force diagram. Now coming back to your next one is your bending moment diagram. Next one is very important, bending moment diagram. How you are supposed to draw the bending moment diagram means simple thing, very easy to draw, right? So in a bending moment diagram, at location point A and point C we are having 0 values. Why you are having 0 values at point A and point C means bending moment means we are having force into some distance. So at point A we are having force, there is no distance. So that at point A we are having 0. And similarly at point C also we are having 0 because you are having force only and there is no distance, so automatically you are having 0 value. Only point we have to left is at point B. At point B means force into distance. What is the force? 50 into 2. So that you are having 100 kilonewtons meters. Right? So this is also same thing. You are having one is the reference line. You can draw a reference line. Above the reference line you are having positive value and below the reference line you are having a negative value. Same thing, above the reference line having positive value, below the reference line negative value. Right, for a simply supported beam or whatever it is, why I have to draw a only straight line, why not a curve or why not a, any other different shapes? Why only we have to draw a straight line means simple thing, simply it has to follow the what we call as the straight line, that is y is equal to mx. So y is equal to mx plus c. So that is one straight line equation. So for a straight line equation, directly you can join these values up. You can directly join these values. So at point A you are having 0, at point C we are having 0 and remaining point B. So point B you are having 100 kilonewtons meters. How do you get this 100 kilonewtons means simple equation. Area under the shear force. Area under the shear force. So area under the shear force means at point B, that is at point B, this is the area you are having. So it is a rectangle block. Rectangle block means this height is 50 and this distance is 2 meters. So 50 into 2, 100. So 100 kilonewton is very easy. No need to calculate remaining things whatever we are having. By simply calculating the area of your given figure, you can easily calculate the value at your desired location. Suppose if you are having a triangle, what is the formula for triangle of area? Half into base into height. Likewise, simply you have to calculate the area under the shear force diagram. Calculate the area under the shear force diagram, you will get the bending moment value on that particular location. This is how you are supposed to draw the bending moment diagram. Right. So you please observe that in a bending moment diagram, I am considering clockwise moment is positive and anti-clockwise moment is negative. And above the reference line I am considering positive and below the reference line I am considering negative. Right. So this is the considerations I am taking while drawing the shear force diagram, bending moment diagram. Similarly for shear force diagram also, for above the reference line positive value and below the reference line negative value. You can consider the vice versa also, there will be no problem. But I am considering for the problems only upward force is positive and downward force is negative. Clockwise mode is positive and anti-clockwise mode is negative. And above the reference is positive and below the reference line is negative. So this is how you supposed to draw the shear force diagram for a simply supported beam with a point load, only point load. In the next class we are going to discussing about the various number of point loads are simply supported by how you supposed to draw the shear force diagram and bending moment diagram, right? Okay.